laws of exponent. So the first law says that a raised to the power of m multiplied by a raised to the power of n can be written as a raised to the power of m plus n. Now all these laws are very important and will come very handy when you are simplifying the complex expressions also. Okay, okay, there are two conditions that you need to take care of. Okay, I'm just going to write this down, just bear with me a minute. So the first condition says that the base value has to be the same. Second condition says that there has to be a multiplication sign. Only then and then you can apply this rule. Okay, if we look at an example, let's say 2 raised to the power of 7 multiplied by 2 raised to the power of 9 is equal to, see, the base value is the same, there is a multiplication sign, so we can just write 2 raised to the power of 7 plus 9, which is going to get me 2 raised to the power of 16. Okay, now the second rule is also pretty much similar. If you understand the first one, the second one is very easy. So it says a raised to the power of m divided by a raised to the power of n is equal to a raised to the power of m minus n. So here you can perform the subtraction for the exponent values. Now here also there are two conditions that I really want to draw your attention to, and it is also the same, that there has to be the same base value and there has to be a division sign. So when there is a multiplication, you add the exponents. When there is a division sign, you subtract the exponents. We are going to take the same example, just going to change the order a little bit. 2 raised to the power of 9 divided by 2 raised to the power of 7 is equal to, base value is same, there is a division sign, so I'm just going to perform, yes, subtraction, right? So the base remains the same, I'm going to perform the subtraction, which is going to give me 2 raised to the power of 2. Pretty simple, isn't it? Now the third law, this is also super easy. So it says a raised to the power of m, and then there is a bracket, and this whole bracket is raised to the power of n. Then you can multiply the exponents. Okay, so there is a bracket sign, there are two exponents involved, then you can just multiply those exponents. Let's quickly look at an example. So let's say 5 raised to the power of 3 raised to the power of 2, then we can just multiply them. 5 raised to the power of 3 multiplied by 2, 3 2s are 6. Okay, that's it. Okay, so now let's look at the next one. This is also super easy, but this is very important, very important. I cannot emphasize enough on this one. So it says a to the power of 0 is equal to 1. So basically anything raised to the power of 0 is going to get you a value of 1. Okay, the only condition is that a cannot be equal to 0. A cannot be equal to 0. Okay, now if we look at the examples, it's, let's say 1000 raised to the power of 0 gets you a 1. 2 raised to the power of 0 gets you a 1. 1 raised to the power of 0 gets you a 1. Let's talk about variables. X raised to the power of 0 gets you a 1. Okay, so basically anything raised to the power of 0 gets you a 1. Next rule says that a raised to the power of negative m is equal to 1 over a raised to the power of m. Okay, This is very crucial and very important to understand. So whenever you get a negative value in the exponent and you want to convert that into a positive value, you just have to flip the position of your base value. So what I mean by that, here the a value is in the numerator and your exponent is a negative value. If you want a positive exponent, just flip the base. So here it is in numerator, here it is going to be in the denominator. If you look at the example, let's say you have 2 raised to the power of negative 1. So your 2 is in the numerator. 2 raised to the power of negative 1. Now I want this to be a positive exponent. So remember what I said, just flip the values, flip the position of the base. Okay, so the base, that is 2, is in numerator. So I'm just going to write it in the denominator with whatever exponent value it already has. Okay, I'm not going to touch that exponent value. For example, let's say you have 3 raised to the power of negative 4. Okay, so just change the value, don't change the exponent. Okay, the exponent value is going to remain the same, just the position of the base value changes. I hope that's clear. The next one, so this one says, let's say if there is ab raised to the power of m, then we can just simply distribute the exponent. Okay, pretty much self-explanatory. Just going to look at an example. Let's say if we have 4x raised to the power of 2, so 4x square. So I'm just going to distribute this exponent, which will now be 4 raised to the power of 2 multiplied by x raised to the power of 2, and later on I can just simplify my if I am being asked. Okay, the next one is also pretty much the same, which says a divided by b raised to the power of m. Then it's just going to be a raised to the power of m divided by b raised to the power of m. Now an example for this one is also going to be, let's say 7 divided by 10 cube. So I'm just going to distribute it. Okay, pretty much simple. Now this next one that I'm going to talk about is going to be a little bit of a trouble, but bear with me. Okay, I'm not sure if this is a part of your syllabus right now for whatever grade you are watching, but this definitely comes in higher grades. So if it is a raised to the power of m over n, now notice that for the very first time you are getting fraction in the exponents. Okay, so if there is anything like this, you are just going to put the base value like this, and whatever is in the denominator is going to be our index value. Whatever is in the numerator is going to be an exponent of the whole bracket. Okay, I know it's very confusing, so we are just going to take some examples. But if we just elaborate this, what does this really mean? So whatever exponent laws that we have covered so far, this just means that it is a raised to the power of m multiplied by 1 over n. Okay, which means that I can just write this as this. Now when we say let's say 3 raised to the power of 1 over 3, okay, we just make a cube root, right? Or let's say 27 raised to the power of 1 over 3, we just make a cube root. Why? Because this value in the denominator is going here and the base remains the same. Let's say we say 4 to the power of 1 over 2, then we just make a square root. Okay, similarly, whenever you have this value here, you are just going to place it as the index value and the exponent remains the same. That's how this comes. So let's look at an example which says 8 raised to the power of 2 over 3. Okay, now if you just get the hold of the formula, you can simply write that 8 remains here, the denominator value goes here, numerator goes here. We all know that 2 raised to the power of 3 is 8. So I'm just going to simplify this, and so this 3 gets cancelled out, and I'm going to get the value as 4. Okay, so that's all about the exponent laws. I hope you enjoyed and you understood the concept. Thank you so much for watching.